Hello my dear students, welcome to IMS Academy. In this particular session, I am going to discuss regarding the network theory subject, the PYQs which are asked in the earlier SSC JEE papers. This is the fourth session regarding network theory subject. So earlier we have done 3 sessions, right? Whoever not watched those sessions, so kindly watch those sessions in your free time. Okay, so this is the fourth session regarding network theory subject regarding the previous year questions of SSC JEE exam. Okay, so whoever attending very first time, whoever visiting our YouTube channel very first time, so all of you kindly subscribe our YouTube channel and click on the bell icon so that you will be getting instant notifications. Okay, you won't miss even single video, right? And all of you kindly like and share this video link with all of your friends so that they also will get benefited from this particular session. Okay, so in this particular session I am going to discuss the network theory questions based on these concepts. Okay, so I am going to cover regarding network theorems, okay, and then the questions based on impedance and admittance, and then the questions based on peak value and RMS value, etc. Okay, right. So this is the question related to the reciprocity theorem. So first read the question. Which of the following is true? Which of the following is true regarding reciprocity theorem? Okay, you're having 4 choices. Just read the statement one by one, and whichever statement is related to the reciprocity theorem, that statement will be correct. Okay, I hope all of you know regarding reciprocity theorem statement, the ratio of response to excitation. Yes, here you're having ratio of response to excitation remains same. Okay, so this is the statement regarding reciprocity theorem. Okay, say for example, you're having one network, you're having one source. Okay, with the help of one source you are applying as an input to that network, and because of this source you are getting the response at the other side. Okay, even if you have interchanged the source and response of the given network, so because of this source, whatever response you got in the other side, the same source when you have placed this side, and because of that you will get the same response on the other side. So that is the meaning related to the reciprocity. Okay, right. Next one, you are having the circuit diagram, and this question is also based on reciprocity theorem. You are having 4 choices, you have to choose the correct one. So in this circuit, just observe, you are having 200 volt source is there and then 100 volt source is there. That means 2 sources are present in the given circuit. Okay, so reciprocity theorem we can apply only when one source is present in the given circuit. But here you are having 2 sources, we cannot apply reciprocity theorem. Okay, so here you can observe reciprocity theorem cannot be applied because it contains more than one voltage source. So option A is correct one. Okay, yeah, next one, this is also based on reciprocity theorem. Here also the context is cannot be applied. Okay, cannot be applied. Reciprocity theorem cannot be applied to the circuit. So just now we have mentioned when multiple sources are present in a given circuit, that time we cannot apply reciprocity, right? So like that, here you are having multi sources. Okay, multi sources is present in only one option, right? Obviously that option will be correct. Here in addition to that you are having non-linear also. Yes. So reciprocity theorem we can apply when in the given network only one source is present, and whatever other than source, rest of the elements should be linear. Okay, if any non-linear element present, then it won't follow the reciprocity theorem. Okay, that is the reason we cannot apply reciprocity theorem for the circuits which contain multiple sources and which contain non-linear elements. Yeah, now this is the question once again based on reciprocity theorem. So just observe here, for the first question whatever I have discussed regarding reciprocity theorem statement, now we can easily apply that theorem now with the help for this particular question. Okay, so just observe this circuit and this circuit. So here you are having 4 resistors, R1, R2, R3, R4. Same resistors were there, exactly same configuration, R1, R2, R3, R4. Okay, right. In this circuit you are having the source here, source is present here 100 volt, and because of this source you are getting the response here. In the R1 resistor the current flowing is 10 ampere. Okay, now the question is they have kept 100 volt source here. That means they have interchanged the source and response. Now you can observe source actually present here. Now from the last stage to they have connected as at the starting stage. Okay, right. and here response you are getting here. Now the response is here. So we can apply reciprocity theorem. So it is very simple. Just observe. Here you are having voltage polarity is plus minus. Okay, because of this voltage source polarity like this, you are getting the current direction downwards. Current direction downwards. Okay, right. Now we can interchange the source and response. That means, so here we can apply 100-volt source. That means the source we can keep here, right? Plus minus 100 volt. That time the current will flow in this particular R3 resistor downwards. Okay, same current, because we haven't changed the magnitude of the source, right? Because of 100 volt you are getting 10 ampere. Now we have interchanged the source and response. Okay, right. Now just observe this circuit. Here in this question, they have placed the voltage polarities minus plus. That means they have changed the polarities of the voltage source. Okay, now I am changing the polarities of voltage source. Okay, if you are changing the voltage polarities, obviously the current direction will change. Okay, so in this circuit, they have given current direction upward. Yes, exactly it is matching. So that means the current I2 will be 10 ampere. So that is the advantage of reciprocity theorem. Okay, because whatever other than source and response, okay, rest everything, like you are having 4 resistors, here also 4 resistors, right? We don't know the values of those resistors, but still with the help of reciprocity theorem, we can easily find in this way response. Okay, right. Similar question, all of you give a try. Similar question. Here in this circuit diagram, they have given the response as 1 ampere because of this particular voltage source, 14 volt. Here you are having plus minus polarities. Now you are having 4 ohm resistor, 20 ohm and then R as it is, but they have interchanged the source and response. Okay, now in this question you have to calculate the current I2. Okay, because of this voltage source 14 volt. Okay, so once again just observe. Here in this circuit you are having plus minus 14 volt. Okay, plus minus 14 volt. Because of that you are getting 1 ampere. Now you can interchange the source and response. That means here I have applied the same voltage plus minus 14 volt. Because of that the current direction will be downward only. In this particular branch, right? But here in this circuit, the voltage polarities, just like in the previous question, you are having the voltage polarities exactly opposite, right? So here the polarities you are getting minus plus 14 volt. Because you have changed the voltage polarities, obviously the current direction will change, right? So here actually downward, now it will be upward, 1 ampere. So in this circuit also the current direction upward only they have given. So that means since it is exactly matching, I2 will be 1 ampere. If suppose they have given current direction in the downward, because actually you are getting upward current as 1 ampere. If they have mentioned downward, then that particular current value will be minus 1 ampere, like that. Whenever the directions are same, you no need to change the polarity. If the directions are opposite, then you have to change the sign. Okay, right. Yeah, this is the question belongs to the first chapter, basics. Okay, all of you give a try. So up to previous question, we have discussed the questions related to network theorems. Okay, so this is once again just in order to give the recap, I have just collected one good question related to the basics. Okay, so in this particular circuit, if you observe, you are having voltage source, 2 voltage sources are present, and then these 2 voltage sources are independent, whereas this voltage source is dependent, and then you are having 2 resistors. So in this question, we have to calculate the voltage across 6 ohm resistor, that is V0. Okay, right. So here you can apply KVL. Okay, KVL you can apply, and for easy understanding or for easy calculation, what you can do, I am considering this voltage polarities as it is, plus minus 12 volt, Now if you observe this particular circuit, in this circuit all the elements are connected in series, right? Okay, all the elements are connected in series, or all the elements together forming a loop also, closed path. Okay, so you can place any elements on any other side. Okay, because all the elements are connected in series, but only you have to take care about the sign carefully, polarities accordingly regarding voltage. So for the time being, we can keep this voltage source here, no problem, because resistor and voltage source are in series. So this voltage source we can keep here and then resistor here, no problem. Okay, so when you are keeping this particular voltage source, okay, I am keeping here, then vertical alignment, then you will get polarities plus minus 4 volt. I hope all of you are getting a clarity. Here plus minus 12 volt, and then this voltage source I have kept this side and then vertical alignment, then this plus sign is coming here and then minus sign is coming at the bottom, 4 volt. So that means here the voltage polarities are same, so we can add the voltages. 12 plus 4 is nothing but 16 volt. 16 volt. So that means here you can observe 4 ohm resistor, 6 ohm resistor are connected in series. In series we can add the resistors, right? Now you can observe here the current flowing in this particular circuit. Okay, the current flowing in this particular circuit is nothing but so with the help of these two voltage sources, resultant voltage you got 16 volt, that is on this particular side. Okay, right. On the other side, so what I am considering, this 4 ohm and 6 ohm together I am considering equivalent resistance 10 ohm, and other side you are having this 1 voltage source. Okay, so 16 minus 2V0 divided by 4 plus 6. I hope all of you are getting the clarity. In series we can add the resistors, and one side you are having this much voltage, other side you are having this much voltage. So voltage difference divided by equivalent resistance, that is nothing but current. Okay, and just by observing this particular resistor, here actually the current is flowing like this, right? The current I is flowing like this. But according to this particular voltage polarities, actually the current flowing in this direction is, by using Ohm's law, you are getting V0 by 6. V0 by 6 is flowing like this, but I current is flowing in the opposite way. Both are opposite, so that means I, we can write it as minus V0 by 6. So from here I am writing I equal to minus V0 by 6. Okay, right. So here 16 minus 2V0 divided by 4 plus 6 is 10. 4 plus 6 is 10. So here 2 3s are 6, 2 5s are 10. You can do the cross multiplication. So from here you will be getting minus 5V0 is equal to 3 16s 48 minus 3 2s are 6, 6V0. Okay, so you can bring this term to the left hand side, it will become positive. 6 minus 5 is nothing but 1. So you are getting V0 equal to 48 volts. V0 equal to 48 volts. Okay, right. So answer for this question is option D. I hope it is clear for everyone. See, if you want, you can apply directly KVL. From there also you can solve the question. But wherever you want to apply KVL, there better you can consider the voltage sources one side, and then with the help of this polarities you can do the calculation simpler. Okay, in this way you can save the time during the exam. Yeah, this also once again question belongs to the basics only. Okay, so just observe this particular circuit diagram. In this circuit diagram you are having one voltage source and rest all the elements are capacitors. Okay, so in this question we have to calculate the voltage across 10 farad capacitor and 40 farad capacitor. Okay, so voltage across 10 farad capacitor they have mentioned V1, and voltage across 40 farad is V2. So V1, V2 we have to calculate. So just observe here in this circuit diagram, 5 farad and 3 farad, these two are connected in parallel. In parallel we can add the capacitances in order to get the equivalent capacitance. So 5 plus 3 is nothing but 8 farad. 8 farad. Now after getting one equivalent capacitance, now tell me how these three capacitors are connected, and even this voltage source and all the three capacitors, how they are connected. Series, right? In series current will be same, but voltage will get divided. Voltage will get divided across every element, right? Now if you want to find the voltage across this particular capacitor, or voltage across this particular capacitor or voltage across this particular capacitor, you can use voltage division rule. Okay, so for this question, let us calculate one parameter. Okay, because you can observe here, see for this question, just observe, even without solving, few options we can eliminate. Can we eliminate or not? All of you can mention in the comment section. See, just observe, the moment you have observed that here you are having one supply voltage and then you are having 3 capacitors, and here we don't have any initial voltage across any capacitor, right? Now with that understanding, so just observe option A, whether we can eliminate or not. Yes, obviously, because you are giving supply is 10 volt, but how we can get 400 and 600? Not at all possible. Straight away you can eliminate. Because you are giving supply as 10 volt, whatever the 10 volt is there, the 10 volt is getting distributed across every element. Yes or no? Okay, some part you are getting here, some part here, and remaining part here. But you are getting more. It's not at all possible. Similarly here, option B, 10 volt and then 40 volt. 40 volt not at all possible. You can eliminate. Okay. And then here option C, option D, you are having 1 volt, 4 volt, 4 volt, 1 volt. Okay, the moment you are calculating one voltage, with the help of that you can easily calculate other one. Okay, right. So here let us calculate voltage across 10 farad capacitor. Voltage across 10 farad. Okay, voltage across 10 farad is nothing but, see, whenever elements are contained in series, across whichever element you want the voltage, that particular impedance will come into the numerator. Okay, so here impedance is nothing but 1 by j omega, 1 by j omega into C1. Here in this case, okay, this capacitor, so that capacitor value is 10. Okay, divided by 1 by j omega into, so whatever the elements here you are having, for every element you can add the impedances. Okay, 1 by j omega into C1 plus 1 by j omega into 40 plus 1 by j omega into 8. Now you can consider the overall supply voltage. Supply voltage is 10 volts. Okay, I hope all of you got the clarity. So what is supply voltage there? That one into across whichever element you want the voltage, that element impedance you have to consider in the numerator, and in the denominator sum of all the elements that are, sum of all the impedances of the elements that are contained in the series. Okay, right. Now let us do the calculation. Here if you observe, this 10 and this 10 will get cancelled. Okay, and 1 by j anyway we can take common and then will get cancelled. Okay, after that in the numerator you are getting, okay, omega also we can get cancelled, right? I hope all of you are getting clarity. 1 by j omega we can take common from numerator and denominator, it will get cancelled. After that this 10 and 10 will get cancelled. So numerator you are having 1, and denominator you are getting 1 by 10 plus 1 by 40 plus 1 by 8. 1 by 8. Now in the denominator term you can take LCM as 40. Okay, so 10 4s are 40 plus 40 1s are 40, 8 5s are 40. Numerator you are having 1. Okay, so this 40 will go into the numerator, divided by 5 plus 1, 6, 6 plus 4 is 10. So that means you are getting 4 volts. Okay, voltage across capacitor 10 farad is 4 volt. Okay, that one here you are having 4 volt in option D. Okay, So the moment you got V1 as 4 volt, obviously V2 is 1 volt, because here no two choices are having the regarding V1, V2 same. Okay, otherwise similar procedure you can follow. From there also you will be getting. There, that time, if you want to get across 40 farad capacitor, then that time you can consider here 1 by j omega into 40. Okay, and denominator term as it is. Okay, so you can follow similar procedure. From there you will be getting 1 volt. Okay, right. So this is an easy question, but when you look at the circuit diagram and when you read the question, some people might have felt that, sir, how to find the equivalent inductance, because they are asking in this question equivalent inductance. But here if you observe, you are having two inductors are there, and here you are having one voltage source, but that voltage source value they have given in terms of dA by dt. The moment they have given in terms of dA by dt, it is very simple. Just apply KVL. Just apply KVL around this particular circuit or closed path. Okay, so here in this particular path, the current I is flowing, and 4 Henry, 5 Henry, both are connected in series. In series, we can add the inductances just like resistors, right? So 4 plus 5, so I am considering that. So the voltage across the terminals A and B is V. Okay, so I am just applying KVL. So minus to plus V. Okay, then here 4 Henry, 5 Henry, both are connected in series. So I am adding the inductances 4 plus 5. Because current is entering like this, the polarities you will get plus minus. Similarly here also plus minus. So that means second polarity is what? Minus. Okay. So that is the reason here I have considered. For every element I am considering the second polarity of that particular voltage. Okay. Right. Then plus 2 minus minus 3 into dA by dt. Sorry, just one second. Yeah, this is the L equivalent into dA by dt. Then plus 2 minus minus 3 into dA by dt is equal to 0. Okay, right. So 4 plus 5 is 9, 9 plus 3 is 12. Both are having negative sign. You can bring to the right hand side, it will become positive. So from here you are getting voltage equal to 9 plus 3 is 12 into dA by dt. So now this one you can equate to the standard formula like L equivalent into dA by dt. So from here we are getting L equivalent as 12 Henry. L equivalent as 12 Henry. So answer for this question is option A. So in this way, whenever you are getting, after reading the question and after observing the circuit diagram, see, if you, in general, when you are having inductors one side, suppose in this circuit also, if this voltage source was not there, okay, then 4 Henry, 5 Henry together, both are connected in series. So you are using the concept of like series or parallel based on the connections present. Okay, but in this question also it is easy because you are having one voltage source. It depends in terms of differential operator with respect to current, right? So just apply, because all the elements forming a loop are closed path, so you can apply KVL around the terminals A and B, right? Okay. Next question, it is very easy question, straightforward question. If you know the basics, you can easily answer without using pen and paper. See, here you are having the circuit diagram. You are having one voltage source and then you are having capacitor. Okay, what they are asking? They are asking the reactance of the capacitor connected to a DC source as shown in the figure. Okay, just write the capacitor reactance formula. Xc equal to 1 by 2 pi Fc. This is the reactance of capacitance. Okay, right. So whenever you are having DC supply, what is the frequency? Yeah, whenever you are having DC supply, you are having the constant. Here you are having voltage source, that means output you are getting constant throughout the time. That means here time will be infinite. If you are taking the reciprocal, frequency will be 0, right? So here frequency will be 0. So when you substitute here, 1 by 0 is nothing but infinity. So Xc equal to infinity. So option B is the correct one. Okay. Next question. So in this question, you have to find out the energy stored in the capacitor C1. At what state they are asking? Steady state they are asking. Okay, I hope all of you know regarding transient terminology and steady state. Okay, so in steady state means t value we have to consider t infinity. Okay, t value we have to consider infinity. So in steady state, capacitor will act as open circuit. In steady state, capacitor will act as open circuit. If you are having inductor, it will act as short circuit. Okay, right. So here you are having capacitor, but since they have mentioned steady state, so you can construct, just you have to remove the capacitor from the circuit. Just remove the capacitor from the circuit, then terminals will become open. After you have removed the capacitor from the circuit, okay, after you have removed the capacitor from the circuit, then terminals will become open. So when terminals become open, obviously there is no current flowing. So if there is no current flowing, there won't be any voltage drop across this particular resistor, 0 volt. And across this open circuit terminals, the voltage will be Vc of infinity, because we are considering at steady state. Steady state means t equal to infinity. Okay. So because there is no drop across this 30 ohm resistor, whatever the voltage here you are supposed to calculate, that is as good as voltage across these two terminals. And here 5 volt source, 10 ohm resistor, both are connected in parallel. In parallel, voltage will be same. So that means without using pen and paper, directly you are getting the answer. The voltage across the open circuit terminals has 5 volt. 5 volt. Okay, right. Now they are asking energy. Energy stored in the capacitor. So that is equal to half CV square. Okay, right. Capacitor value is 20 farad. Then voltage, just now we got 5 whole square. Okay, here 2 10 times. Then 5 square is 25. 25 into 10, that is 250. Units are joules. 250 joules. So answer for this question is option C. Okay, right. Next question. So now we are going to solve the questions with respect to impedance and admittance, etc. Okay, right. So in this question, they have given the impedance value and they are asking the corresponding admittance. I hope all of you know the relation. Admittance is nothing but reciprocal of impedance, right? So y equal to 1 by z. So here z they have given as 3 plus j4. Okay, right. Now what you have to do? Just observe the choices. Here you are having like a minus jb or a plus jb format, and option B you are having 0. Okay, so that means you have to multiply and divide with complex conjugate. Okay, multiply and divide with complex conjugate. So here 3 plus j4, complex conjugate is 3 minus j4. Right. So numerator you are getting 3 minus j4. Denominator, I hope all of you know the standard formula. When you are having a plus b into a minus b, you will get a square minus b square. But here you are having a plus jb into a minus jb. That means you will be getting a square plus b square. Because when you have written a square minus b square, j square is nothing but minus 1. Minus into minus is plus. That means you are getting a square plus b square. So directly you can write 3 square plus 4 square. I hope all of you got the clarity, right? Now 3 square is 9 plus 4 square is 16. 9 plus 16 is 25. Then numerator you can keep as it is, 3 minus j4. Okay. Now if you observe the choices, you are having like real numbers or integer numbers like this, right? So that means you don't have like fractional part, like ratio of 2 numbers, like that format was not there. So to do the calculation simpler, here in the denominator you are having 25, right? So for doing the calculation simpler, I am multiplying and dividing with 4. So that what will happen? So 25 into 4, we can write it as 100. Numerator, you just multiply. 4 3s are 12. minus 4 4s are 16 j. Now divide with 100 is very simple, right? So you have to put decimal point after 2 digits, right? 12 by 100 you can write as 0.12. Yes or no? Okay. Minus 16 by 100 you can write as 0.16 j. 0.16 j. Here for this question, for understanding purpose, we solve the question. But when you look at the choices, after reading the question regarding the impedance, you are having 3 plus J4, directly we can eliminate wrong choices. Yes or no? You just observe. Here A plus JB format, you are getting the denominator. When you are multiplying and dividing with A minus JB format, denominator anyway you are getting some constant, positive value. Numerator you are getting A minus JB format. A minus JB. That means imaginary term you should get negative. This is the common sense. Yes or no? This much observation you can do without using pen and paper, because you are having both real part and imaginary part is there. So when you multiply and divide with complex conjugate, after doing further simplification, you are getting like regarding imaginary part, regarding imaginary term, you are getting negative. This is the conclusion point. The moment you are getting like this, you are having in only one choice, right? Straight away we can choose. But here for calculation point of view, in order to get familiarity, I have solved the question completely. So in this way, whenever you are solving any question in the SSC JEE exam, just because you are having choices, just have a look at the choices. If you are able to solve after reading the question, and if you are having the basics command, then whether I can choose directly the correct option or not without using pen and paper. If there is a possibility, do it. But at least in some questions you can eliminate the wrong choices as well. Okay, wherever that possibilities are there, better do it so that you can save the time during your SSC JEE. Okay, right. Yeah, next question. All of you give it right. Yeah, in this question, they have given the admittance. Admittance they have given, and they are asking the impedance. Okay. Admittance they have given, and they are asking the impedance. Okay. So here, impedance is nothing but the reciprocal of admittance. Reciprocal of admittance. Okay. So here, okay, before doing the calculation, just by observing the given circuit, okay, by observing the given data, y value they have given 0.03 minus j 0.04. Okay, for easy understanding, I am modifying like this. 3 minus j4 divided by 100. Can we write like this or not? Yes, we can easily write. 3 by 100 is nothing but 0.03 and 4 by 100 is nothing but 0.04. Just like the previous question, for easy understanding, here I have multiplied and divided with 4. After that denominator we got 100. That 100 we have split for both real part, imaginary part, right? Like that. Okay, if you are having like this, you can write like this, or if you are having like this, you can write like this, vice versa. Okay, wherever simplification is possible, accordingly that time you can do the arrangement like that. Okay, right. Now you can substitute this y value here. So from here what you are going to get, z equal to, you have to take the reciprocal. So that means 100 is coming in the numerator, and denominator you are getting 3 minus j4. Now here also you multiply and divide with complex conjugate, because here all the options you are having like A plus JB format. Okay. So here multiply and divide with 3 plus j4. Okay. So denominator what you are getting, A square plus B square. Yes or no? So here 100 I am keeping as it is, and then 3 plus j4 also as it is. Now 3 square is 9 plus 4 square is 16. So that means you are getting 25. So 25 here 4 times. Now you can multiply 4 with both. So 4 3s are 12 plus 4 4s are 16. 12 plus 16j. Yes, we are having an option. In this way, if you are able to do the adjustment, you can get the answer quickly. Okay, right. Next question. In this question, you are having the admittance. Okay, admittance they have given 3 plus j4. Now they are asking the resistance. Resistance they are asking. Okay, so if you want to get the resistance, what you have to do? First of all, just do the reciprocal of this admittance. So that means you are getting the impedance. From impedance, we can get the resistance easily. Okay. So Z equal to 1 by Y. So 1 divided by 3 plus J4. Okay. Directly I am writing. You will do multiplication and divide with 3 minus J4. After doing like that, you will be getting 3 minus J4 divided by. Denominator you are getting 3 square is 9 plus 4 square is 16. That means 25 you are getting. So I am splitting into two parts, 3 by 25 minus j into 4 by 25. So you are having real term and then imaginary term. In this question they are asking resistance, right? So resistance is nothing but the real part of the impedance. Okay. So that means 3 by 25. So option D is the correct one. Option D is the correct. Okay. Next question, all of you give a try. Yeah, just observe in this question you are having two impedances are there, Z1, Z2, and both are connected in parallel. And here you are having the supply current for that particular parallel connection, you are having 15 ampere. Okay. Now the question is the total admittance of the circuit they are asking. Total admittance of the circuit. Okay, right. So see, if the elements are connected in series, we can add the impedances. Similarly, if the elements are connected in parallel, we can add the admittances. Okay. So in this question, they are asking the equivalent admittance. Total admittance they are asking. So I am writing here Y equivalent equal to Y1 plus Y2. Now Y1 is nothing but 1 by Z1. Y2 is nothing but 1 by Z2. 1 by Z1 plus 1 by Z2. Okay. Right. So here 4 plus J3 plus here you are having 8 minus J6. I am taking 2 as common. Okay. I am taking 2 as common so that you will be getting 4 minus J3. 4 minus J3. You can observe here 2 4s are 8, 2 3s are 6. Yes. Okay. Now once again you multiply and divide with complex conjugate. Okay. So from there, here you will be getting 4 minus J3 divided by 4 square is 16 plus 3 square is 9. Direct step I am writing 25. 16 plus 9 is 25. Similarly here 4 plus J3 divided by 2 into. Here also 16 plus 9, that is 25. 16 plus 9, 25. Okay. So here in the denominator, you can take 50 as the LCM. 50 as LCM. So here I am multiplying with 2. 2 into 4 minus J3 plus here 1 time 4 plus J3. Okay. So here you can observe 4. Yeah. Here you are having real term and then imaginary term. You can do the simplification easily. Okay. So 2 4s 8 plus 4, that is 12. 8 plus 4 is 12. Then minus 6j plus 3j, that means minus 3j divided by 50. Divide by 50. Okay. So here in all the choices you are having like A minus JB format or A plus JB format. But up to now, after doing the calculation, you are getting like this, right? So with this understanding, we can eliminate these two choices because you are getting A minus JB format. A minus JB format. Okay. In order to do the calculation simpler, just observe denominator you are having 50, multiply and divide with 2. Multiply and divide with 2. Okay. Right. So from here you are going to get. Okay. So numerator you are getting 2 12s are 24 minus 2 3s are 6 divided by 2 50s are 100. Okay. Now you can easily represent the values. 24 by 100 is nothing but 0.24 minus 6 by 100 is nothing but 0.06. Okay, right. So 0.24 minus j 0.06. Yes, option A is the correct one. The moment you are getting option A is correct, option B we can eliminate. Okay, So even here also, option A, option B, if you observe, regarding the corresponding real part is different, regarding the imaginary part it is different. The moment if you are able to get the real part, with the help of that also you can easily answer the question. In this way, whenever you are solving any SSC JEE question, no need to solve the question completely. After reading the question, have a glance about the choices, just observe the choices. From the choices you are getting the clue, okay, whether we can eliminate 3 wrong choices or whether we can eliminate 2 wrong choices, like that. Whatever possibility is there, first do it, or with the help of partial solution, at least you can do it. In that way you are saving the time. In that way you are figuring out among the given choices which one is correct in less time. Okay, if you are able to follow this strategy, then definitely you can attempt more number of questions in the given time. Otherwise, you are solving the question completely. After that, if you are attempting, you are getting very less time. Okay, you are able to solve very few questions. Okay, right. So all of you try to avoid the regrets. Okay, if you want to avoid the regrets, you follow these kind of strategies, then definitely whatever the questions you are supposed to attempt, which you are supposed to attempt in the given time, definitely you are getting enough time. You can able to attempt those questions, so that after the exam over, there won't be any regret. Okay, right. Yeah, next question. This is a question related to the resistance basic formulas. Okay, so here in this question, actually question solving wise not at all tough, but only thing regarding the terminology, whether you are having one particular word terminology, you are having the synonyms or not. Okay, just in order to get that familiarity, I have kept this question here. So in this question, if you observe, they are asking resistance per meter. Resistance units are what? Ohm per meter. Per meter length they are asking. That means ohm per meter you are getting. So here resistance per meter length of a wire. Okay, so calculate the resistance per meter length of a wire. Okay, in this question they have given all the units are ohm, but it should be like ohm per meter. Ohm per meter. Okay, fine. Resistance per meter length of a wire of diameter 40 millimeter and specific resistance of 3.14 into 10 power minus 4 ohm meter. Okay, I hope all of you know this formula. R equal to rho L by A. Rho L by A. In this question, they are asking resistance per meter length, right? So this length you can consider this side R by L. Okay, and here rho divided by A. So area is nothing but pi r square, and since they have given diameter, you can write another formula like pi d square by 4, because r is nothing but d by 2. You are getting pi r square by 2. Okay, so pi area is nothing but pi r square, where r is nothing but d by 2. So d square by 4 you are getting. Okay, right. So in this question, in general, you know that rho is nothing but resistivity. But in this question, they have given specific resistance. Both are same. Resistivity and specific resistance both are same. Okay, once if you know this wording, then you can easily solve. And one more interpretation here, since they have asked resistance per unit length or per meter length, so this length you are bringing this side. That is the only twist in this question. Okay, so here rho value they have given 3.14 into 10 power minus 4 divided by pi, you can keep as it is, divided by 4 into d square. Okay, diameter they have given 40 milli. Milli we can write as 10 power minus 3 whole square. Right? Okay. So pi value is nothing but 3.14. So pi and 3.14 will get cancelled. Then here you can observe 10 into 10 power minus 3 is nothing but 10 power minus 2 whole square is nothing but 10 power minus 4. Numerator also you are having, it will get cancelled. So finally what you are getting, so this 4 will come into the numerator, and here 4 square you are having 16. So from here you are getting 1 by 4. 1 by 4. Actually the unit should be ohm per meter, because they are asking per meter length, right? That is okay. In general, resistance if you are having, units will be ohm, but since they have asked per meter length, so unit should be ohm per meter. Here also in options it should be ohm per meter, but they have assumed that it's like resistor, so that is the reason they have given like units are ohm, but it should be exactly ohm per meter. Okay, but anyway 1 by 4 you are having only one choice. In this way, in some questions, like if they are not taking care about the units like very appropriately. If they're unable to, no problem, but have a look at the choices regarding the magnitude wise. Here 1 by 4 you're having exactly one choice is matching, so whichever is like more appropriate that you can choose. Okay, right. Yeah. Next question related to the inductor. So in a pure inductive circuit, if the frequency of the AC source is doubled, if the frequency of the AC source is doubled, then its inductive reactance will be. Its inductive reactance will be. So earlier we have discussed with respect to capacitive reactance. Now the question is with respect to inductive reactance. So XL equal to 2 pi FL, XC equal to 1 by 2 pi FC, whereas XL equal to 2 pi FL. Okay. Now in this question they have mentioned that frequency is doubled. Okay. Frequency is doubled. Now rest everything you can keep as it is. So here I am considering like first case XL. Now the second case I am labeling as XL2. Okay. So when compared to the first one, here what happened? The entire quantity become double, right? So 2 times XL. So here the inductive reactance, whether it will become 0 or remain same or half or double. Answer is option D. It will become double. Okay. Next question. It is very easy question, theoretical question. Just observe, all of you read the question once and try to choose the correct option. So in this question you are having, in electrical circuit, the current that changes periodically both in magnitude and direction, okay, at regular intervals of time. So whenever you are having the like this characteristic, then that particular signal we are calling it as obviously AC signal, alternating current. In short we can call it as AC signal. Okay, it is changing both magnitude and direction. Okay. Yeah. Now just observe this question. In this question, the earlier question also with respect to current and this question also with respect to current, but there is a slight difference. Here in this question the current varies periodically. Earlier also periodically, here also periodically, but now only there is a twist. You can observe it is changing from 0 to maximum. Okay, you are having 0 and then maximum, 0 maximum, 0 maximum, like that. So in one interval you are having 0, another interval you are having like maximum value, like 5 ampere, 12 ampere, like that. Okay, another interval 0, another interval once again maximum, like that. If you are having, then that particular, and it is repeating, and then it repeats. Okay. So whenever you are having like this, that is nothing but pulsating signal. Yes or no? You are getting pulses. Okay. Next one. So in this question you are having, you are supposed to calculate the voltage across 5 microfarad capacitor. Okay. You are having supply voltage in terms of AC signal. AC signal. Okay. You are having voltage and you are having the capacitor. Now you have to calculate. Okay, they have given the voltage. Now you have to calculate the current. How much current is flowing in that particular capacitor? That is the question. Okay. So I hope all of you know the standard formula. IC equal to C into dV by dt. IC equal to C into dV by dt. See, in the initial classes, initial sessions, we have discussed the questions based on the standard formulas with respect to resistor, inductor, capacitor. Once again we are using, but only the difference, there we have considered with respect to like DC source, and here we are considering with respect to AC source. Okay, right. So here capacitor value is 5 micro. Micro we can write as 10 power minus 6, 5 micro. Now this entire quantity we have to perform the differentiation. Okay, so direct step I am writing. So here 40 is the constant, we can keep as it is. Now derivative of cos term, you will be getting minus sign. Derivative of cos, you will be getting minus sign. 6000 T as it is. Okay, and then regarding this 6000 T, once again you have to perform differentiation. From there you will be getting 6000. Because derivative of T with respect to T will be 1. Okay, right. So once again I am repeating this capacitor value and then differentiation of this particular voltage signal. Okay, right. Now overall expression you are going to get negative, and here also you are having negative two choices. So based on that we can eliminate two choices. We can eliminate two choices, right? And here you are getting sine term, okay? And sine term you are having here, okay? Directly we can choose. So option B will be correct. Whether we are getting this 1.2 or not, now let us verify. Okay, minus sign we got, sine 6000 t we got, okay? But 1 whether we are getting or not, we can verify. Right. So just observe here, you are having 10 power 3 into 10. That means 10 power 4, 10 power 4, and 5 6 are 30. 5 6 are 30. Okay, I will write like this. 5 6 are 30. 30 into 4, that is 120. 120 into here 10 power 4. Okay, sorry. Yeah, 10 power 4. Here 10 power minus 6 is there, that I am writing like this. 10 power 4 into 10 into 10. Okay, just for calculation simpler. Okay, 10 power 4 I kept as it is, and then 100 is there, 10 into 10 I have written. And then rest everything you can copy as it is, like minus sign 6000 t. Okay, right. Here 10 power 4, 10 power 4 are getting cancelled, and 10 is getting cancelled. 12 by 10 is nothing but 1.2, and then you are having minus sign. Yes, minus 1.2 into sine 6000 t. Units are ampere. Okay, so answer for this question is option B. I hope all of you got the clarity. Even if you not solve the question completely, with the help of partial answer, with the help of partial solution, how easily we are able to eliminate the wrong choices and how we are able to get the correct option, right? I hope all of you will apply these kind of strategies in your SSC JEE exam. Okay, right. Yeah, next question. This is a question based on maximum power transfer theorem. So here you are having AC source, and then here source impedance is there, and then load impedance is there. Okay, in this question, in order to get the maximum real power, that means across the load resistance. Okay, right. In order to get the maximum real power, now the load impedance value will be. I hope all of you know the standard formula and relation regarding maximum power transfer theorem with respect to AC. In order to get maximum power across the load resistance, okay, so in order to get the maximum power across the load impedance, right? So ZL equal to ZS conjugate. ZL equal to ZS conjugate. So here source impedance you are having 9 plus J6. So for this you have to perform complex conjugate. So that is nothing but 9 minus J6. 9 minus J6. So units are ohm. Here in this question they are asking the maximum power across the load impedance. Okay. So that particular units, when you are getting ZL equal ZS conjugate, what will happen? Here plus J6 and minus J6 both will get cancelled. You are having resistor, here also resistor. So that means what is the power here across the load impedance you are getting? That is the real power. That is the meaning of here maximum real power. Okay, don't get any confusion. Maximum real power they are asking. So when you are getting ZL equal ZS conjugate, in this entire circuit diagram you are having AC supply. The rest of the circuit is like purely resistive part. Okay. Right. Yeah. Next question. Which of the following statements is not correct? See, it is very important. In some question they can ask which of the following is correct. In some question they can ask which of the following is not correct. According to the context, you have to answer the question accordingly. Okay, right. So here frequency is reciprocal of time period. That is a true statement, but they are asking not correct, right? So here time period is the number of cycles per second. This is the wrong statement, hence it will be the correct option for this question. See, frequency is nothing but number of cycles per second. In 1 second, how many cycles it is happening with respect to the voltage signal or current signal. Okay, right. So, but here they have mentioned time period, so that is the wrong statement, hence it is the correct one. Okay, right. RMS value is 0.7 times peak value. That is correct statement only, because RMS value is nothing but peak value divided by root 2. 1 by root 2 is nothing but 0.707, or in short you can write 0.7. That is a true statement. And peak value, peak voltage is another name for amplitude. Yes, all are same. Okay, so other than option B, option A, option C, option D, those are the correct statements. Okay. Yeah, next question, you are having the current expression. Okay, so for this current expression, they're asking the max amplitude. Whenever you're having cos signal or sine signal, so whenever you're having time domain signal like this, okay, you'll be having here whatever the constant value you're having, that indicates magnitude or it indicates peak value or voltage, all are same. Okay, so in this question it is the current, so this is with respect to current. Suppose if they have mentioned voltage, according this the peak voltage or amplitude of that particular voltage signal. Okay, since they have mentioned current, it will be the maximum amplitude of that particular current signal or peak value of the current signal. So answer will be 50 ampere. So whenever you're having sine or cos, so that time you're having here amplitude, and then from here you are getting the frequency term. Okay, it is like omega. Here you're having omega you can write as 2 pi f. From there you can get the normal frequency also, and then you're having phase angle. Okay, this is a time domain signal with respect to cos, or similarly you'll be having sine. Okay, whenever sine or cos signal is present, that time you are getting three parameters. One is amplitude, another one is frequency, another one is phase angle. Okay, right. So here in this question, the peak value of an AC signal or alternating current is 8 ampere. Peak value they have given. Now they are asking RMS value. RMS value they are asking. So just now we have mentioned RMS value is nothing but Im by root 2. RMS value is nothing but peak value divided by root 2. Here in this question, peak value is 8 divided by root 2. So here multiply and divide with 2 root 2. Because why I am multiplying? Because you can observe the choices. You don't have like ratio of two numbers, right? That is the reason, in order to get the simplified answer. Okay, since you are having root 2, multiply and divide with root 2. So that in the denominator you are getting 2. Okay, 2 here 4 times. That means 4 root 2. Units are ampere. Okay, 4 root 2 ampere. So that means option C is the correct one. Option C is the correct one. Right. Next one. The instantaneous current is given by, okay, you are having the current expression like this. Now they are asking RMS value. Similar question. IRMS equal to Im by root 2. IRMS equal to Im by root 2. Here Im value is 4. 4 divided by root 2. Just like the earlier calculation you can do, multiply and divide with root 2. So from there you will be getting 2 root 2. Similar question. Option B is the correct one. All of you give it right. Next question. See, the formula for RMS value of sinusoidal signal in terms of peak to peak voltage they are asking. In terms of peak to peak. Okay. So in this question they have mentioned with respect to voltages. So accordingly I am considering. In the previous question they have mentioned with respect to current. I have considered the current notation. Here in this question they mentioned with respect to voltage. Accordingly voltage notation. That's all. Okay. So RMS value is nothing but the peak value divided by root 2. Peak value divided by root 2. But here they are asking in terms of peak to peak. Okay. So here whatever the peak value you are having, okay, that one if you want to write in terms of peak to peak, so peak to peak divided by 2 is nothing but Vm. Or in other words we can say peak to peak voltage is nothing but 2 times the peak value. Okay. Divided by root 2 as it is. So from here what you are getting? V peak to peak divided by 2 root 2. Option A is the correct one. Okay. This 2 and root 2 both are in the denominator. You can multiply. Okay. V peak to peak divided by 2 root 2. Yeah. Next question. This is also easy question. So here you are having the fundamental frequency 25 Hz. Now they are asking the corresponding angular frequency. Whenever they are asking angular frequency, that means it is omega. Or even you can observe here choices, you are having radian per second. See, angular frequency units are radian per second, not radian. Radian means radians are the units for phase angle. Okay, so here without solving this question also, you can eliminate two choices. Okay, now I am using the standard formula regarding omega. There is nothing but 2 pi f. And here they have given frequency as 25. Okay, substitute here. 2 pi into 25. So 225 sir 50 into pi. Units are radian per second. Units are radian per second. So option A is the correct one. Obviously, we can eliminate option C. Okay, right. Okay, I hope it is clear for everyone. Yeah, in this particular session, we have discussed total 26 questions, right? So all these questions, okay, in this particular session, we have discussed some questions related to network theorems. Okay, we have discussed with respect to reciprocity theorem, and then with respect to AC also we have covered with respect to maximum power transfer theorem as well. And then we have discussed the questions with respect to impedance or admittance. When they have given impedance, they're asking admittance, or they have given admittance, they're asking the corresponding impedance or any one parameter like resistance or reactive component, etc. And then with respect to peak value, RMS value also, we have solved the questions. Okay. So in this particular session, whatever the questions we have discussed, right? So these sessions are going to help for all the SSC JEE aspirants who are writing the exam in this particular year. Okay. And even for future also. Okay. I hope all of you got maximum benefit from this particular session. Okay, so all of you kindly like and share this video link with all of your friends also, so that they also will get benefited from this particular session. Okay, so now I am going to give two important updates for everyone. So the first update is regarding our Telegram channel. So the link is already provided in the description of this video. All of you kindly join if you not yet joined till now. Okay, say for example, currently whatever the upcoming sessions are happening in our YouTube channel, all those sessions timetable or schedule you are going to get in this particular Telegram channel, and whatever faculties are writing during the class, okay, on this particular digital board, whatever we are writing, right, that particular notes we are going to share in the PDF form. That PDF also we are going to share in this particular Telegram. Okay, and then you are all of you are getting all the important updates related to whenever we are going to conduct any seminar or webinar, and even you are getting the job notifications as well, okay, related to the government job notifications, PSU job notification, etc. On daily basis, we are posting one quiz question in our Telegram channel. So all of you are getting great opportunity to learn one question of the day. Okay, right. So it is all these features you are getting for free of cost. So whoever not yet joined till now, all of you kindly join in your free time. Okay, and one more important update. At our IMS Gate Academy, we are having live online program that we are offering for the students who are writing the GATE exam in the 2025 or 2026. Okay, so all these are the features of our live online program. Whoever interested to join at our IMS Gate Academy for this live online program, all of you can contact to any of these two numbers. Our counselors will discuss in detail about our live online program features, and even if you are having any doubts regarding our course features, you can inquire them. Our counselors will discuss in detail. Okay, so here you can observe whatever the resources required for any aspirant to get very good rank. So here at our IMS Gate Academy, we are providing each and every resource. You can observe here the number of live classes we are providing 800 plus, and we are providing for every subject, we are providing the theory book, exercise book, and in the exercise book we are having 4000 plus practice questions, and then we are providing 34 plus years GATE question bank. Okay, and here this is one of the special book that we are providing for all the enrolled students, right? So here in this GATE question bank, we have provided wherever required, we have provided the alternate solution. Even for typical questions, our faculty have provided the video solution as well. Just you have to open the QR scanner in your mobile, then the respective video solution will be played. And then we are providing 130 plus various tests in our LMS portal, and then we are providing 12 MyPlan sessions for every enrolled student, so that they can get the proper guidance and study plan in order to do their GATE preparation smoothly, and in order to get their good success in the coming GATE exam as well. Okay, right. So all these benefits you are getting, whoever interested, okay, for the upcoming years, whoever want to write the GATE exam, for all the students, for all the aspirants, okay, this particular program is going to help. So all of you can contact to any of these two numbers. Okay, right. And not but not the least, all of you kindly subscribe our YouTube channel if you're not yet done. Okay, and then click on the bell icon so that you will be getting instant notifications. Okay, all of you kindly like and share this video link with all of your friends, so that whatever the session you got benefited from this particular, in this session we have discussed good number of network theory questions. Similarly, even your friends or whoever want to write the SSC JEE exam in this year, even upcoming years, even for them it is going to help a lot, right? So all of you kindly like and share this video link so that they also will get benefited from this particular session. Okay, so we'll meet you all in the next session. Thank you everyone.